Hello, math fans. Take a moment to give yourself a pat on the back because this is Test 17, Lesson 6, the last math lesson of grade 6. And today we're going to review how to give reasonable estimates, how to draw angles, and how to identify triangles by their angles. And at this point, everything should be review. So let's start by giving reasonable estimate. So here's a sample question. What would be a reasonable estimate for 128 times 35, and how do you know it's reasonable? So here's the thing. When you're looking at a reasonable estimate is an estimate that makes some kind of sense. So 128 times 35, well, if I did, for example, 100 times 40, that would be 400. So I know 400 would be reasonable because I rounded one down and one up. I kept them at about the same place. An unreasonable estimate would be 4,000. Because how would you ever get to 4,000 from this? You know, 100 times 100 would be 1,000. So this isn't even in the hundreds. It would be totally unreasonable to think that it would be in the thousands. Okay? So basically what we're talking about here is how to make a reasonable estimate and explain that it's reasonable. So here's a similar question. Is 4,030 a reasonable estimate for 40 times 10? Why or why not? The answer obviously is going to be no, it is not a reasonable estimate. Why? Because how would I get to the thousands with 40 tens? I have to count by tens 10 times just to get to 100. And here I'm only counting by tens 40 times. So how would I get up to 4,000? So here's an example of what you could write for this question. It is not a reasonable estimate because 40 times 10 should give an answer in the hundreds. You would need to multiply hundreds to get an answer in the thousands. It is not a reasonable estimate. Sorry, that bugs me. So this is an answer that you would get full marks for on a test. And that's all we're doing here. We're just talking about how to make estimations and explain your thinking. Next up, let's review how to draw angles. So here I'm asked to draw an angle of 75 degrees. So remember, one of your lines, we call them rays, must always be on the 0. And the vertex of your angle, or the corner of it, needs to be at the vertex mark on the angle. On the protractor. So next, to get to 75 degrees, I need to come up like that. So there's an angle of 75 degrees. Remember, when you're measuring, you need to start at the 0. If I had started over here, then I could use the blue numbers, and I would have an angle of 75 degrees like that. It doesn't really matter which side you start on, but you have to start with the 0. So here I'm asked to draw an angle of 340 degrees. Now again, you can see my protractor only goes up to 180. So what I'm going to do is I know that a full circle will be 360 degrees. So if I take a full circle and I take out the amount I need, 340, I will get 20 degrees. So that means if I draw an angle that's 20 degrees, so I'm going to put one line on the 0, and I'll just get it where it's supposed to be, one line on the 0, and the other line going to 20 degrees, and that doesn't work because it's not starting on the vertex. Sorry, it's a little hard to be precise with my iPad. Okay, so that's a 20-degree angle. I want to draw an angle of 340 degrees. I know that the rest of the circle will be 340 degrees. So this is a 340-degree angle, and it's a reflex angle. And here's one more example. Draw an angle of 213 degrees. Once again, my protractor only goes up to 180. So once again, I'm going to do 360, take away 213. This is going to be another reflex angle. And that's going to tell me how big my interior angle should be. So that's going to equal 7, 4. That should equal 147 degrees. So again, as always, one line goes on the 0, and my vertex goes at the dot or line, depending what your protractor has. My other line is going to start there and go to 147. So I'm going to start at 0. And sweep it around to 140, 145, 146, 147. So that means this interior angle is 147 degrees. That's not what I want. I want 213 degrees. So I'm going to make my angle a reflex angle and go around the outside. And that should be an angle that is 147 degrees. And hopefully this is all not new to you. And last up, just a quick review of how to identify triangles by their angles. So here we go. Equilateral triangles, all sides and angles are the same, which means that the angles must be 60, 60, and 60 degrees, because triangles, the angles must add up to 180. A scalene triangle, no sides are equal and no angles are equal. Isosceles triangle has two sides and angles that are equal. The third one is different. A right isosceles is where one of the angles is a 90-degree angle. And an obtuse triangle, we call a triangle an obtuse triangle if one of its angles is greater than 90 degrees. So that's your little review. If any of this is confusing to you, you should be going over these definitions for sure. And here I have a totally optional activity. You don't have to do this at all. But if you would like to watch the last episode of Maths Mansion and see how the show ended, it is at www.tinyurl.com/mathsmansiontheend. So you don't have to watch that. The review is up next and you can just do that and quit there. But if you would like to see the end of Maths Mansion, because we've watched quite a few of them this year, that's where you'll find it. And here is your final review of grade 6. Number 1, explain how you can make sure an estimate is reasonable. Number 2, use your protractor to draw the following angles: 112 degrees, 33 degrees, and 181 degrees. And 3, given the following angle measurements, what kind of triangle is shown in each question? A is 60 degrees, 60 degrees, 60 degrees. B is 90 degrees, 45 degrees, 45 degrees. And C is 110 degrees, 30 degrees, and 50 degrees. And we are done. So that's it. See you tomorrow. Thank you for being such a wonderful math class this year, and have a good night.